Welcome to homework.
In this problem, we have an RLC circuit, and we have to show that the fraction of the energy lost in every cycle of the oscillation is going to be equal to 2 pi times the resistance over the angular frequency times the inductance. How do we do this? First, we write down what is the maximum charge in a cycle. The maximum charge in a cycle is going to be given by the initial charge times e to the minus RT over 2L. And then we want to find what is the maximum charge in the next cycle. So the charge in the next cycle is going to be the initial charge, e to the minus r, but we're going to replace the time by the time plus the period, because the time it takes to complete a cycle is equal to 1 period. So there we have it. That is the maximum charge within the next cycle. Then we're going to use the formula that the energy is equal to charge squared over twice the capacitance, and we're going to plug in the respective charges into the energies. So the maximum energy within one cycle is going to be given by Q squared over 2 times the capacitance times E to the minus RT over L, and the energy in the next cycle is going to be given by Q squared over 2 times the capacitance times E to the minus R plus T plus the period over the inductance. So the quantity that we're looking for is the change in energy between one cycle to another, more specifically the fractional change in energy. So this is going to be equal to, because this is decaying, so this quantity is bigger than that quantity. So in order to get a positive quantity, we're gonna be doing here U1 minus U2. So this is going to be E to the minus RT over L minus E to the minus R times T plus period over L over the initial energy E to the minus RT over L. And this is equal to 1 minus E to the minus RT over L. Now, we're going to be using, in order to actually find the expression that we need, we're going to be using a Taylor series to expand this term. So this is going to be E to the minus RT over L. We expand this using a Taylor expansion. So this is equal to 1 minus RT over L plus some quadratic terms that they're not going to concern us in here. So we're only going to be using the linear part, okay? So then after plugging that into there, we get that delta U over U is equal to 1 minus RT over L, which is equal to RT over L. Now, this T is the period, and we know the relationship between the period and the frequency of the circuit. So this is equal to 2 pi times the resistance over omega L. And this is the answer that we were looking for. So just to clarify, for that step, we use the fact that the period is equal to 2 pi over omega.